Hey, welcome to our channel. I'm Geetanjali, your math coach, and today we are going to learn HCF or highest common factor of two or more numbers. In this video, we will learn why do we need HCF and how to find HCF of two or more numbers in a few seconds using Vedic math techniques. I'll explain you with the help of a few examples, and at the end of the video you will find summary where you can have recap of all the methods. To begin with, where do we need HCF of two or more numbers? Let's try to understand by a few real-life examples. For example, there is a carpenter who has got some free wooden planks. Some are 12 meter long and some are 18 meter long. He wants to cut them up so that he has equal sized planks to make using them easier. What bigger size planks he should cut them into to avoid wasting any wood? Suppose carpenter doesn't know mathematics much. Now he would start with trial and error. So suppose he tries cutting bigger size planks into half. So everything he got of 9 meter. But here you can notice in this part these are 3 meters long, which may get wasted. But he want to make maximum utilization of entire collection whatever he has got. So he will try something else. Now suppose he wants to cut everything of the smaller size plank. So what will happen? He will get here 12 meter long, but this 6 meter long from these two planks will get wasted. But yes, of course, he can notice that this is 6 meter and these are 12 meters. If he cut them into half, he get all of equal size. So his problem is sorted out. Now, if a mathematician look into it, he can reach to the solution very fast if he knows what is HCF. So let me explain you HCF. HCF is the highest common factor of the number. So to find HCF of the numbers, first of all, we'll take all the numbers involved here. Here the numbers are 12 meter and 18 meter. So 12 and 18 are the numbers. Then we find their prime factors. 2 6 are 12, 2 3 are 6, and 3 1s are 3. Now 18, 2 9s are 18, 3 3s are 9, and 3 1s are 3. So factors of 12 and 18 are, 2 times, 2 times, 3, and factors of 18 are 2 times, 3 times, 3. The next step will be, we will take common factors of both the numbers, which is in this case 2 and 3. So HCF of 12 and 18 would be equals to product of these two numbers, which is equals to 6, and this is our answer also. So let's look at the formal definition of HCF. HCF of two or more numbers is the greatest number which divides each of them exactly. Now let's understand method with one more example. Suppose Meena wants to plant 45 corn plants, 63 sunflower plants, and 81 carrot plants in her garden. If she puts the same number of plants in each row and each row has only one type of plants, what is the greatest number of plants she can put in one row? Oh, it's a difficult situation for Meena. But as you know what is HCF, and we can help Meena in this case. So to find HCF of the numbers, first we consider all the numbers involved here. There are 45, 63 and 81. Now let's find their factors. Factors of 45, we can divide 45 by 3. 3 1s are 3, 3 5s are 15, 3 5s are 15, and 5 1s are 5. Factors of 63. 3 2s are 6, 3 1s are 3. 3 7s are 21, and 7 1s are 7. Now factors of 81. 3 2s are 6, 3 7s are 21, 3 9s are 27, 3 3s are 9, and 3 1s are 3. Let's note down all the factors here. Factors of 45 are 3 times 5. Factors of 63 is equals to 3 times 7. And the factors of 81 is equals to 3 times 3, all 3's. The next step, we'll find common factor in all 3 numbers, which is equals to 3 into 3. So HCF of numbers 45, 63 and 81 would be equals to 3 times 3, that is equals to 9. Now you can suggest Meena that she should plant 9 plants in each row. Look at her garden, how beautiful it looks now. So as you must have understood the concept of HCF, where we should use it. I will explain you method once again with the help of one more example. For example, we have to find HCF of two numbers 56 and 120. So first step, we will find prime factors of 56 and 120. So we will start dividing it by 2. We take smallest number first, which can divide the number. 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 7s are 14, and 7 1s are 7. Now 120, 2 6s are 12, 2 3s are 6, 2 1s are 2, 2 5s are 10. Now we need to divide it by 3, 3 5s are 15, and 5 1s are 5. Now let's note down these factors. Factors of 56 are 2 times 2 times 2 times 7. And factors of 120 are 2 times 2 times 2 times 3 times 5. Now the next step, HCF of 56 and 120 is equals to their common factors, which is 2, 2, and 2, which is equals to 2 times 2 times 2 is equals to 8. So HCF of 56 and 120 would be 8. Now I think we have done enough practice of finding HCF of two or more numbers by prime factorization method. This method is called prime factorization method. In this method, we find prime factors of all the number involved, and then we find their common factors and multiply them to get HCF of the numbers. Now I will explain you a few shortcut techniques how you can reach to the result very fast. So to follow shortcut techniques, first of all you need to observe all the numbers very carefully. So I will explain you with the help of example one by one. For example, in this case, the number involved here are 8 and 16. So we observe whatever is the smaller number, whether that number divides bigger number completely or not. If it is dividing bigger number completely, it means that smaller number is HCF of both the numbers. For example, in this case, 8 divides 16 completely. So HCF of 8 and 16 would be equals to 8. Just by observation you have found out result. No need to find their factors. Let's take one more example. For example, 30 and 45. Smaller number is 30. Does it divide 45 completely? No, it does not. So the next step will be, we will find difference of these two numbers. Difference is 45 minus 30 is equals to 15. After finding the difference, we figure out whether it divides both the numbers. Yes, 15 divides both 30 and 45. 15 2s are 30, 15 3s are 45. So HCF of the numbers 30 and 45 is equals to 15. You have reached to the solution so fast. Now let's take one more example. The numbers are 150 and 216. 150 doesn't divide 216. Let's find its difference. 216 minus 150. It gives you 66. Next step. Does 66 divide both 150 and 216? No, it does not. So we need to add up one more step here. Instead of finding factors of 150 and 216, now we will find factors of 66. Factors of 66 are 2, 3s are 3s are, 3, 1s are 1s are, 11, 1s are. So the factors of 66 are, factors of 66 are 2 times 3 times 11. Now the next step is we take both the numbers together, 150 and 216. Now we will try to divide these numbers by that number which divides both the numbers completely, and it should be factor of 66. So let's take 2 first. 2 divides 150 and 216 completely. 2 7s are 14, 2 5s are 10, 2 1s are 2, 0, 2 8s are 16. Now let's take second factor. It is 3. 3 divides 75 and 108, yes. So 3 2s are 6, 3 5s are 15, 3 3s are 9, 3 6s are 18. Now the next factor is 11. Does it divide both 25 and 36? No, it does not divide even a single number. So the factors of 150's highest common factor of 150 and 216 would be product of these two numbers, which is equals to 6. So HCF of 150 and 216 is 6. So instead of finding factors of each of these numbers, we simply find factors of their difference and then try to divide these numbers by the factors of that difference. Whatever factor divide both the numbers completely will be factors of these numbers. Now let's go to next example. Suppose you have to find HCF of 37 and 42. 37 doesn't divide 42. We take that difference. 42 minus 37 equals to 5. Does 5 divide any of these numbers? No, it doesn't divide any of these numbers. Can we factorize 5 further? No, we cannot. It's only factors of 1 and 5. So the HCF in this case would be equals to 1 because they don't have any other common factors. See, in one step only you could find it out. Now next, suppose there are more than 2 numbers. Now what we do? The same method which you have followed in the previous example, we will find difference. But difference of what? Here we choose all the possible pairs, like 112 minus 98 is one pair, 196 minus 112 is another pair, and 196 minus 98 is the third pair. Now we find difference of all these. Here difference of 112 and 98 is 14, and the difference of 196 and 112 would be 84, and difference of 196 and 98 is 98. The next step will be we will choose the smallest difference. Here in this case it is 14. So we start finding factors of 14. Factors of 14, or we will try to divide. Let's try it here. Without finding even factor, we can find the HCF as 14 divide all 3 numbers completely. If you remember table of 14, 14 7s are 98, 14 8s are 112, and 14 14s are 196. So no need to find factors of 14. HCF of 98 and 112 and 196 is equals to 14. We have found our answer. just in a few steps. Now let's take one more example. If the numbers are 253, 378 and 882, same method, difference between 378 minus 253, this is equals to 125. Now let's take difference of 882 minus 378. By observation you can tell that this difference is going to be bigger than 125. This difference is going to be bigger. So why to waste our time? We will not find this difference. And the other pair will be 882 minus 253. This difference will be even bigger than this difference, so no need to find this difference also. So we will have to choose 120 and we will have to find factors of 120. Factors of, sorry, it's not 120, it's 125. Factors of 125 are 5 times 5 times 5. But 5 doesn't divide any of these numbers, so there is no common factor. So HCF of 253, 378 and 882 is equals to 1. Look at this question. If you try to find factors of all these numbers and then try to find common factor, it would take so much of time. Just in one step you could find there is only one common factor, and that is 1. So here is a summary. Whatever you have learned in this video, you can go through it and revise all the steps once again. If you have any question or any ideas that you want to like us to present, please leave a comment below. Check out also our other videos. Thank you so much for watching, and if you like it, please don't forget to subscribe.